This video is integrated 3, the chapter 12, D-Day number 2, Olive is the name of this one. So on numbers 1 through 3, we are going to try to solve the trig equation. Now, when we have a situation like number 1, where we just have a sine squared, you want to get the sine squared by itself, everything else on the other side. So in order to do that, I am first going to add 1 to both sides. And I'm going to get 4 sine squared x equals 1. Then I'm going to divide by 4, and I get a 1/4. And the last step, I'm going to take the square root. And when I take the square root, I get a positive and a negative. And when I take the square root of a 1/4, I take the square root of a 1, which is a 1, and the square root of a 4, which is a 2. So I'm looking to see where my sign is equal to a positive and negative 1. We also want to pay attention that they want for all x. So this is where I might have to add and subtract, for example, 2 pi n or 2 pi k, whichever variable you want to use. So first thing I'm going to do is, in this case, I'm going to have it in every quadrant because my sign is positive in these 2 quadrants and my sign is negative in these 2 quadrants. So I'm going to be getting answers in all of these sections. Now my sign is the y coordinate. And so I want my y to be 1/2, or what I call short. So when I'm doing this, I'm going to be going long comma short. So I'm going to be right here, which is pi 6. And that means I'm going to be also at all my other pi 6. So this is going to be 5 pi 6. This is going to be 7 pi 6. And this is going to be 11 pi 6. Now, sometimes you can write all of these answers using just 1. So if I'm looking at my pi 6, can I add something to pi 6 to get to 5 pi 6? Well, the distance from here to here is 4 pi 6, because pi 6 plus 4 pi 6 is 5 pi 6. But the distance from here to here is only 2 pi 6. So in this situation, I can't just take pi 6 and add and subtract something to get to all of these. What I do notice, however, is that some of these are pi away from each other. So these ones are pi away from each other. So one answer is going to be pi 6. And since they're pi away, I can add and subtract pi. So pi 6 plus or minus pi n. That's going to get me the 2 that are on that purple line. My 5 pi 6 and my 11 pi 6 are also pi away from each other. So another answer is going to be 5 pi 6 plus or minus pi n. So those are my answers. On number 2, in this case, I have a cosine squared minus 1 is equal to 0. So I have just a cosine squared. So I'm going to get that isolated. So I'm going to have cosine squared x is equal to 1. I'm going to take the square root of both sides. And when I do, the square root of 1 is a positive and negative 1. Now my cosine is the x coordinate. So my cosine is 1 here, because that's 1 comma 0, and here because that's negative 1 comma 0. So that's going to be at 0 and pi. Now these are pi away from each other. So I can add pi to get to here. And then if I add another pi, I end up coming all the way back to here, which would be 2 pi. So my answer is going to be 0 plus or minus pi n. So I can add and subtract pi to 0, and I can get to each of my answers. Now you could clean that up and just write it as plus or minus pi n. Those really are the same. On number 3, this is a situation where I have a cosine squared and a cosine. I am going to think of this as a quadratic, and I want to get everything on one side, 0 on the other. So I'm going to have 2 cosine squared x minus cosine x minus 1 equals 0. If you want, you can rewrite this kind of thinking of it as the following. I'm just going to use a different variable just to not confuse anyone. So I can write this as like a 2m squared minus 2m minus 1 equals 0 and solve. So that would be a 2m times an m in the fronts. I have a minus 1, and I need to get a negative 2m here. So I'm sorry, a negative m here. I apologize, that's not there. Okay, so I'm going to put negative 1 here and a positive 1 here. And so what's really happening is we are going to have this equal to 0. And so this would be m is equal to a negative 1/2, and this would be m is equal to 1. Now, remember, this wasn't an m, these were cosines. So then you could rewrite it as cosine x equals a negative 1/2 and cosine x equals 1. Myself personally, I usually just leave my cosines in this and just write a cosine x times a cosine x. Well, a cosine 2x, 2 cosine x times a cosine x. And this is going to be a negative 1, and this is going to be a positive 1. And I'm going to do the same thing. What would make this 0? Well, I would end up subtracting 1, and then I would end up dividing by 2. So you see, I get that same cosine of a negative 1/2 that I got over there. And here my cosine x would equal 1, which again is the same thing I got over here. So I'm looking for those answers on my unit circle. So my cosine is my x again. And so first off, my cosine is negative in quadrant 2 and 3. That's where my cosine is negative. So for this portion, I'm looking there. Now my cosine is positive in this portion here. Okay. So that's where I'm going to be looking for the second one. So for the cosine x is equal to a negative 1/2, I am looking for my x to be short. So short, long. This is where I am. And that is a thirds. This is a 2 pi thirds. Now it's also going to be down here, which again is still a thirds. This is 4 pi thirds. Now let me get my cosine x equal 1. So my cosine x equals 1 is going to be right here at 0. Now, what you do want to kind of take a look at is to see, hey, can I get from here to here, and then to here, and then to here using the same amount? So when I am going from 0 to 2 pi thirds, that would be 2 pi thirds away. When I'm going from 2 pi thirds to 4 pi thirds, I would be adding 2 pi thirds. So that's also 2 pi thirds away. And to go from 4 pi thirds to here, well, let's see. If I add 2 pi thirds onto this, what would happen? So if I take 2 pi thirds plus 4 pi thirds, that would push me to 6 pi thirds, which really is 2 pi. So in this case, I don't need to write all 3 separately. I can write all of them using x is equal to 0, and I'm going to add and subtract 2 pi thirds times n. On numbers 4, 5, and well, they've got 2 5s here, 4, 5, and 5. What we're doing is we're verifying. Okay, I'm trying to get the left side to look like the right side. So I am going to be keeping this cosine of 0 of theta. I want the other side to become that. So a couple things that I'm going to say. Cotangent is equal to 1 over tangent. However, I have a cosine over here. I have no cosines on the left side. So is there a way to get a cosine? Well, what I know is that the cotangent of theta is equal to the cosine of theta over sine of theta. So I'm going to use that. Something else I know, the cosecant of theta, that is 1 over sine of theta. So I can rewrite the left side. The cotangent of theta is going to be a cosine theta over sine theta. And then that is being divided by cosecant theta, which is 1 over sine theta. And again, our goal is to get cosine theta. Now, when I am taking cosine of theta over sine theta and dividing it by this 1 over sine theta, remember, when I'm dividing by a fraction, I can multiply by the reciprocal. So I can really rewrite this as cosine theta sine theta. Instead of divided by 1 over sine theta, it's going to be sine theta over 1. Okay, again, that was that fraction. I just flipped it. Now I'm trying to get a cosine of theta. I noticed that I can do some simplifying. This sine theta and this sine theta will cancel out. And when I do that, I am going to be left with cosine theta equal cosine theta. And that will be my answer. On number 5, when I'm verifying this, I am trying to get a cosine squared x over 1 minus sine x. So first thing I notice is I have no denominator over here. So what I'm going to do is I can put this whole thing over 1. And when I do that, I am going to try to get a 1 minus sine x as my denominator. So I'm going to take a 1 plus sine x over 1. And I am going to times top and bottom of this fraction by a 1 minus sine x, because I want to get a 1 minus sine x in my denominator because I have that over here. So that's my goal, is to get that. And again, this is going to equal cosine squared x over 1 minus sine x. So what I'm going to do is I am going to take 1 minus sine x times 1 plus sine x. You can work that out using a box, but I'm just going to jot down over here. This is really the same as a minus b times a plus b, which is a difference of 2 squares. I am going to get an a squared minus b squared. So when I am doing this here, 1 minus sine x times 1 plus sine x, I am going to get a 1, because 1 squared is 1, minus sine squared x. That's what I'm going to get. On bottom, I'm going to have a 1 minus sine x is equal to cosine squared x over 1 minus sine x. Now, this right here, I'm going to try to make it become this. So I got to figure out how I can do that. So what I do know is that 1 minus sine squared x is making me think of the following. Sine squared x plus cosine squared x equals 1. That's one of the Pythagorean identities. So if I was to subtract sine squared x from this side and this side, I'm going to get that cosine squared x is equal to 1 minus sine squared x. And what we'll notice is that is the same as this. So in place of that, I'm going to write cosine squared x. So this is going to be cosine squared x over 1 minus sine x. And you see, I have verified it. I got that on both sides. On the next number 5, we're trying to verify that these are equal. So again, I'm going to focus on keeping this. Now, just like I did above, I am going to be looking at a difference of two squares, a minus b plus a minus b times a plus b. And that is equal to a squared minus b squared. So when I am doing this secant x minus 1 times secant x plus 1, that is going to become secant squared x minus 1. And this is equal to tangent squared x. Now, one of the formulas that we have, and I'm just going to just remind us, if I was to take sine squared x plus cosine squared x equals 1, that is the Pythagorean identity used above. If I was to divide everything by a cosine squared x, now we have this actual formula listed, but sometimes if I don't have it listed, I can just derive it here. This is really going to be a tangent squared x. This is going to be a plus 1. And 1 over cosine squared x is going to be secant squared x. So now what I'm trying to get is I'm trying to get this. So what I'm going to do is I'm going to minus 1, minus 1. And when I do, I get tangent squared x is equal to secant squared x minus 1. Again, we have this formula. Let me highlight it. This formula on our sheet. Okay, so you don't have to derive it. But you do want to minus the 1 from both sides so that you can recognize that this, this is the same as this. So in place of my secant squared x, I can write tangent squared x instead of the secant squared x minus 1. And so I get tangent squared x equals tangent squared x. Done. On number 6, this is the cosine of 2a. And we have a few formulas for this. So when I am dealing with the cosine of 2a, and I know my sine, I will say this. This is in quadrant 3 because they tell us. So you could draw this out. This would be angle A. Sine of angle A, this is going to be my negative 3 because this is opposite and this is going to be hypotenuse. If I do Pythagorean, I am going to get a 4 here. And it's going to be a negative 4 because it's on the negative side of the x-axis. So now we have some 3 formulas that we could pick from. So the 3 formulas that we can pick from are right here. These are the 3 formulas. So if you did not want to find your cosine, we could have just used this one here. Now that I found all parts of my triangle, I could use any of these. Okay, let's just say I use the second one, 1 minus 2 sine squared x. So I'm going to use that cosine of 2a is equal to 1 minus 2 sine squared x. So sine squared a, because this is angle A. So if that's the one I'm doing, I really didn't have to work that out because I already knew what my sine was. So if I'm going to go 1 minus 2 sine squared a, what I'm going to do is I'm going to go 1 minus 2 times my sine, which is a negative 3/5, and I'm going to square that. That's going to give me 1 minus 2 times 9/25. And then that's going to give me 1 minus 18/25. So when I take 1 minus 18/25, that is going to end up giving me 17/25, and that is our answer. Number 7 and 8 are review from our systems. So this one is a parabola. So I am going to substitute this one in, this one in, and this one into the equation. So for the first one, I am going to get 2 is equal to a times 1 squared plus b times 1 plus c, which cleans up to 2 is equal to a plus b plus c. Then my next one, I'm going to have 3 is equal to a times 2 squared plus b times 2 plus c. That's going to give me 3 is equal to 4a plus 2b plus c. Now you want to be careful with this last one. It's going to be 6 is equal to a times a negative 1 squared plus b times a negative 1 plus c. What we want to be careful with is this. When I square a negative, I should be getting a positive. So this should be a positive a, not a negative a. Then it's a minus b plus c. Now I have all of these equations, and so I can do one of two things. I could choose either A or B to eliminate. B would actually not be that bad to eliminate here, but what is always going to be true every time I do this, I'm always going to have a plus C, a plus C, and a plus C. So usually I'll just kind of use that to help me. So what I'm going to do is I'm going to multiply this one by a negative 1. And when I do, I'm going to get negative 2 is equal to negative a minus b minus c. And I'm going to use that with the other two equations. So I'm going to use that with 3 is equal to 4a plus 2b plus c. So when I add that up, I am going to get 1 is equal to 3a plus b. I am going to take that same equation, negative 2 is equal to negative a minus b minus c, and this time use it with the other equation. 6 is equal to a minus b plus c. And I'm going to add that one up. When I do that, I end up getting 4 is equal to, my a's actually cancel out, my c's cancel out, and I get a negative 2b. So I actually am going to find my b here. My b is going to be a negative 2. At this point, what I'm going to do is I'm going to substitute that into this equation to find my a. So I am going to go 1 is equal to 3a minus 2. I am going to add 2 to both sides. So I'm going to get 3 is equal to 3a, and I get a is equal to 1. The last thing I need to do is find my c. So to find my c, I think I'm going to go into the original first equation, which was 2 is equal to a plus b plus c. So I'm going to get 2 is equal to 1 minus 2 plus c. So 2 is equal to negative 1 plus c. I add 1, I get 3 is equal to c. So my equation is going to be y is equal to 1x squared, which is just x squared, minus 2x plus 3. That is our equation. Now on the next problem, so what we want to do is end up eliminating one variable out of these and end up getting 2 equations with 2 variables. So if I'm looking at my x's, or I'm looking at my y's, or I'm looking at my z's, I want to figure out which one's the easiest. I probably would stay away from my z's. My y's would cancel really easily, the -3y and the +3y, but I have to do a little more effort with the 2y. So I think I'm going to do my x's because I have this one here that has just x, so I can times that by anything to eliminate the other two. So I am going to call this one equation 1, this one equation 2, this one equation 3. And I am going to eliminate x. That's what I'm going to do. So first thing I'm going to do is I am going to multiply my equation 1, okay, which is x minus 3y minus 5z equals -5 by a -4. And when I do, I'm going to end up with -4x plus 12y plus 20z is equal to 20. And then I'm going to take that one with equation 2, which was a positive 4x. That's why I times it by a -4, minus 2y plus 3z is equal to 13. And I'm going to add these two equations together, and I'm going to get a new equation. These are going to cancel out. I get a 10y plus 23z is equal to 33. Can't simplify that at all. Sometimes you can. I'm going to call this equation 4. So I'm again going to take equation 1. So I'm just going to do it up here. Which was x minus 3y minus 5z equals a -5. And this time, to help eliminate my x in equation 3, I am going to multiply by a -5. So I'm going to get a -5x, a positive 15y, a positive 25z is equal to a positive 25. And then I'm going to add that with equation 3, which was a 5x plus 3y plus 4z equals 22. And I'm going to get another equation that should have y's and z's. So my x's cancel out. I get 18y plus 29z is equal to 47. And this will be equation 5. So now I have this system with y's and z's. Okay, so what I'm focusing on now is this and this as a system. Now, looking at the y's and the z's, neither one of them is going to be easy to eliminate. To get rid of the 29 and the 23, I'd have to multiply both of them by the other one. And same with my 18 and my 10. I think I'd rather multiply by an 18 and a 10, honestly, than a 23 and a 29. But you can go either way. So I am going to multiply this, let's say, by a -18. So I'm going to take my 10y plus 23z equals 33 and times it by a -18. I'm going to get a -180y minus, and 18 times 23 is a -414z, and 18 times 33, I'm going to get a -594. Looks kind of yucky. I'm going to do the same idea up here with my equation 5, but I'm going to multiply it by a positive 10. And so when I multiply everything by a positive 10, I get 180y plus 290z equals 470. So now let me take this to here. And so I have a -180y minus 414z is equal to a -594. I'm going to combine. My y's cancel out. 290 minus 414 is going to leave me with a -124z. 470 minus 594 is going to leave me with a -124. as ugly as it looked, I'm going to end up getting z is equal to 1. So at this point, my two equations 4 and 5, that system, I'm not done solving because I need to still find my y. So if I had a choice between these two, I think I'm going to use equation 4. Okay. So for equation 4, what I'm going to do is I'm going to have 10y plus 23 is equal to 33. So 10y is equal to 10. And so y is equal to 1 also. So now I'm going to take my y and my z and into 1, 2, or 3. I'm leaning towards 1 because that has just a plain x as opposed to a 4x and a 5x. So I'm going to be looking at equation 1. So I'm going to have x minus 3 times 1 minus 5 times 1 is equal to negative 5. So x minus 3 minus 5, x minus 8. I'm going to add 8 and I get x is equal to 3. So remember, this is a point. Okay. So I always write my x first, then my y. So this is going to be 3, 1, 1. And that's our answer. Okay, on 12, okay, this is an exponential equation. My goal is to first get this by itself. So what I have to do is to get rid of anything that's adding or subtracting. So that 24 is adding, I need to get rid of that. So when I do that math, I get a negative 4 times 5 raised to the 6x minus 1 is equal to a negative 16. Now, again, my goal is to get this by itself. So I am going to divide by a negative 4, divide by a negative 4. I'm going to get 5 raised to the 6x minus 1 equals 4. At this point, I'm going to rewrite this as a logarithm. So I'm going to write this as log base 5 of 4 equals 6x minus 1. Okay, I'm just rewriting that exponential as a logarithm. Then I'm going to put log base 5 of 4 in my calculator. Okay, and so when I do that, let me just put it in my calculator. Log base 5 of 4. I end up getting a 0.861, let's say 4 if I round. I'm going to add 1 to both sides. So I'm going to get a 1.8614. I'm going to divide by 6 and I get a 0.310, let's say 2 as my answer. On 13, we're trying to subtract. So what I'm going to do is I need to first factor both of these denominators. So I am going to have x over x plus 5 times x minus 5 minus, and I'm going to do this plus a negative 6. And this is going to be an x plus 5, x minus 4. So what I need to do is I need to get a common denominator. So this one here, I'm going to multiply top and bottom by x minus 4 because the other one had an x minus 4. Both of them had an x plus 5, so I don't have to do anything with that. But this one I need to multiply by an x minus 5 because this one didn't have that. And then I'm going to distribute. So I'm going to have x squared minus 4x minus 6x plus 30. And this is going to be all over x minus 4, x plus 5, x minus 5. And when I clean up the top, I'm going to have x squared minus 10x plus 30 And the bottom is going to be an x minus 4, x plus 5, x minus 5. Now, if I'm trying to decide if that can be factored on top, I would be thinking what multiplies to 30 and adds to negative 10. Well, 1 and 30, 2 and 15, 3 and 10, 5 and 6. None of these are going to work. So this is my answer. I can't factor it and simplify. I'm done. On 14, this is another verify. Okay. And so when I'm trying to verify this, what I want to do is I want to, again, keep this side as is and try to get that. So I am going to get a common denominator. So what I'm going to do is the sine x over 1 plus cosine x. I am going to multiply top and bottom of that by a sine x and a sine x. The other fraction, which has a 1 plus cosine x on top, I am going to multiply top and bottom by what it was missing, which is a 1 plus cosine x. Now, when I do this, now you see both denominators are going to have a sine x and a 1 plus cosine x. So I'm going to do the math here. So I'm going to get sine squared x. Now over here, when I do this, this is a perfect square trinomial. So when I do that, that's really an a plus b squared, which ends up being squaring the first a squared, multiplying them together and doubling it, 2ab, and then squaring the n. So I am going to get a 1. When I multiply my 1 and cosine x together, I get a 2 cosine x after I double it. And then I'm going to square my cosine, so I get a cosine squared x. Now, all of this is going to be over the denominator, sine x times 1 plus cosine x. And again, what we're trying to get is 2 over sine x, 2 over sine x. Now, the one thing I notice is that I have a sine squared x and a cosine squared x. That is going to equal a 1. So just a little reminder that sine squared x plus cosine squared x equals 1. That is a Pythagorean identity. So those are going to become a 1. I have plus a 1 plus 2 cosine x all over sine x plus, times 1 plus cosine x. And again, we're trying to get this to be a 2 sine x. So I am going to have 1 plus 1, which is 2, plus 2 cosine x, again over sine x times 1 plus cosine x. And we are trying to have this equal a 2 over sine x. So the next thing I'm going to do, let me just add a page. Is Sorry, it was taking a minute to load. So again, what I just did was I took this 1 plus 1 and got a 2. So I have 2 plus 2 cosine x. Now I'm trying to get a 2 over sine x. So what I can do is I can factor out a 2 from both of those terms. And I'm going to have 2 times 1 plus cosine x over sine x times 1 plus cosine x. And again, we're trying to get 2 over sine x. I have this 1 plus cosine x and this 1 plus cosine x, which are going to cancel out. And I am going to be left with a 2 over sine x. And that's what I wanted. So I verified it. And that's the end of this video.